Okay. Hello, everyone. I'm Dewan Farid, Associate Professor, Department of Computer Science and Engineering, United Nations University, Bangladesh. Thank you for inviting me here in JuliaCon 2019. So this is a lighting talk, so I'll have 10 minutes. So briefly, I will talk about introductions because I saw that some of the people are from different discipline, and I will talk about the proposed method and other of my works and results and data sets. So my research work is about machine learning for data mining applications in big data. You can search me in Google, and you can search me in Google Scholar, so you can have my papers. So in JuliaCon, actually, basically, this is the first attempt from Bangladesh. So there are four co-authors. Dr. Shatabda, he's a associate professor in the same department, and Mohammad Joinul Abidin, he's a postdoc, currently doing his postdoc in China. Actually, he's the source of the data set, and these two, Tariqul Islam and Istiaq Hussain, is our undergraduate students. So basically, it's done by our undergraduate students. So data mining is so couple of slides. I'll just quickly go through. So data mining is the process of extracting knowledge from data. It's very simple. It's a multiple discipline of machine learning, advanced artificial intelligence, or knowledge discovery from data. So machine learning basically the technical basis for data mining. So their learning process, supervised learning, unsupervised learning, semi-supervised learning, active learning. So these are very known terms. So I just skip these things actually. So there are 5 processes. So we need to collect data, and then we apply data preprocessing, feature selection, apply mining algorithms to have the knowledge. So these are the 5 processes. So as I don't have enough time, so I'm just moving quickly. So the title is Mining Imbalanced Big Data. So currently, last 1 year, I'm working with big data. So big data is basically volume, variety, and velocity. And there are many challenges to mine big data, to extract knowledge from the big data. So the volume is the issue, that we cannot store all the data in a single machine or in a single computer. That's another challenge. So we need to actually divide the big data into several chunks. And normally I do apply rainforest and boost up aggregation for tree construction algorithm. That's really I'm familiar with. And variety is that in big data there are different types of attribute values or feature values. And normally in the literature I found if a data set contain at least 10 features, input features, we can consider it as a big data. And velocity is like streaming data. Data is continuously generating. And when data is continuously generating, there is a challenge for concept drifting. So the property or the importance of a feature can be changed over the time. So there is another challenge. And we may add another few V's like vision, verification, validation. So I'm just going to the next slide. So the thing is mining imbalanced data. So if it is imbalanced, so if you look at the first figure, this is a top figure, there are 2 kinds of dots, blue dots and red dots. So actually we can consider each of the dot as a data point or vector or instances. So normally in imbalanced data, so majority class instances, say for example blue dots actually dominating the red dots, and if we build a machine learning algorithm or any type of classifier which is actually biased to the blue dots, like majority class instances, and ignore the minority class instances. And there are few methods, established methods. One of the best approach is data sampling. So we have 2 sampling approach, undersampling and oversampling. So what we can do in undersampling, we can remove some majority class instances and make the data set balance. It's fine. And for oversampling, what we can do, we can create some artificial or synthetic data for minority class instances to make the data set balance. And there's a problem in these two cases. So if you do undersampling, if you remove majority class instances, then you may lose some valuable information. In most of cases, random undersampling is very popular, but yeah, you may lose some informative informations. And for the oversampling, it's like an overfitting problem. So you are actually adding artificial data, so you are actually, it's like an overfitting problem. So so we have another methods like cost-sensitive measure or ensemble learning methods. So cost-sensitive measure is also very popular, but the problem is to find the accurate misclassification cost for majority class instance or minority class instance. And ensemble learning is another learning approach which is very commonly used for dealing with imbalanced data. Say, for example, adaptive boosting or AdaBoost algorithm. So in each iteration, what it do, so in AdaBoost algorithm, it basically first iteration, it basically selects some random instances, initially give the weights to all, equal weights to all instances and select the random instances and build a model and classify or try to classify the training data using the model. And the interesting thing is, so as the majority instances are from blue dots or majority class instances, so it will pick majority class instances and build the model. So there is a chance to misclassify minority class instances. So in AdaBoost algorithm, what actually do, it actually increase the weight of the misclassified instances and decrease the weight of correctly classified instances. So in the next iteration, there is a chance to have misclassified instances, which is basically the minority class instance to build the model. So this is an approach. So now, so this is a common diagram, like for example, if we have imbalanced data, so we just divide the data into majority and minority, so training and testing sets, and from training and testing sets we actually divide the majority and minority classes, apply data sampling techniques and build the model. So it's very common. So there are a few common algorithms, most popular algorithms like Smooth, which is a oversampling method, AdaBoost that I talked about, random undersampling with AdaBoost, Smooth Boost. So these are very common, these are the most popular data sampling methods. And actually this is a result. We measure the performance based on some benchmark dataset from UCI machine learning repositories. So there are two open source software. One is called Keel, which is a knowledge extraction based on evolutionary learning, which is a Java-based software. So they actually implemented 45 imbalance classification algorithms. So if you visit there, you can have these algorithms. And also there is a Java-based tool called Swakkhar, so which is also implement the ensemble learning algorithms like random forest, bagging, boosting, these things. So our idea is an undersampling approach, but not to remove majority class instances randomly. What we do, we actually try to cluster the majority class instances, and from each cluster we try to extract informative instances. So the idea is the instances, those who are close to the center of the clusters or border of the cluster, they are the informative instances. So the idea, we published the paper in Berlin conference in Europe in 2016, and then we just modify the approach for JuliaCon 2019. Like, say, for example, we just give a boundary to the close to the center of the cluster. So from each cluster, we just give a boundary and pick the instances from that boundary. So, and we just keep a separate test data to validate the model, and we got more than 90% accuracy. It's really interesting. So the data we collected is a synthetic data. It's like a telefraud data, and you can see that there were about 83 lakhs of instances, and the ratio of majority and minority class instances, which is really imbalanced, and there are total 11 input features, including one class features. So our job is to classify either it is fraud or non-fraud. So these are the input features. So it's really interesting that for classifying imbalanced data, we cannot measure the accuracy. We need to find the precision and recall values. So which is basically positive class rate or negative class rate. So, and also you can consider FE score, F1 score, right? So these are some results. We just divide the data set and make the clusters, and finally for average result we got 97% of accuracy and precision. And so almost is really very interesting to have this result. And we also collect some benchmark data sets. So 44 benchmark dataset from UCI machine learning repository, and we compare our approach to other approaches, and we found that it's really work. So based on this idea, we published a paper in 2017 in Scientific Reports by Nature. So Farid and the first author and second author is my undergraduate students. Farid currently doing PhD in University of Manchester. And we published another paper on CFS Boost, and then a couple more papers, 7 conferences. So I'd like to thank Julia for giving me the JuliaCon Travel Award. So my travel here is awarded by Julia. So thanks, Julia, organizer, every member related to Julia. Thank you very much. And I would like to share information like that. Professor Alan Edelman visited Bangladesh 2017. Actually, he introduced Julia to us, and then we make a forum, Julia User Forum in Bangladesh, and every month we do some activities, some kind of meetings or training, TO2 trainings to promote actually machine learning with Julia in Bangladesh. So recently we have an activity, so that's called JICon, which is Julia in computation, intelligent computing. So we actually give an open competition. So anyone from the world, even from outside of the Bangladesh, they can participate. They can submit their Julia code, and there's some prize money. And winning team will participate next JuliaCon in 2020. So this is the things. And thank you from United Nations University. Thank you very much.
Thank you. All right, thank you everybody for coming. And also we don't have time because we have a photo op, right? So everybody please leave and go out to the building and turn left. We all supposed to gather together so we can take a picture.